My name is Nick Sims, 4132 St. Charles, New Orleans, Louisiana. Thank you. All right, well, good evening. As Claude said, my name is Nick Sims. I'm a project manager with the Corps of Engineers, and tonight I'm going to give an update on the Calcasieu River Basin feasibility study. This is a drainage study that we've been conducting for the past few years that is looking at flood reduction measures in gravity drainage districts 4, 5, and the city of Lake Charles. Next slide, please. Quick rundown of what we're going to go through tonight. First, we're going to look at the project background, go through the scope of work, see what exactly we were tasked to do with this study. Look at our plan formulation process. This will go through the alternatives that we looked at to reduce the flood measures in the area. Go through our alternative screening, look at some floodplain maps so you can see when we did run these reduction measures where the flood stages were reduced in certain areas. Look at our preliminary alternative analysis that goes into our economic analysis. Look at what we think is the recommended plan at this point, and then finally our path forward. Next slide. Okay, background on the study. In 2001, the Corps completed a favorable reconnaissance study. In the civil works process, which is what this particular study is in, the first phase is the reconnaissance study. You go through and you look at the area, just a broad area, see if you have any type of problem, and see if there is a federal interest for this problem. With this study, we looked at Bayou Dienne. We saw that there were some flooding problems in that area. We didn't really go into how we can alleviate these problems, but we saw that there was a federal interest. So that allowed us to move into phase 2, which is the feasibility phase of the civil works process. We moved into that phase on May 3rd, 2005, when we signed a feasibility cost share agreement with the police jury. Now, the City of Lake Charles and the Drainage Districts 4 and 5 are also our cost-sharing partners, but the police jury is the official partner for this study. And what we had was a $2.3 million study to, like I said, try to alleviate some of the drainage problems in the area. It was cost-shared at 50-50, 1.15 coming from the Corps and 1.15 coming from the police jury, the city, and the 2 drainage districts. Next slide, please. Okay, the scope, what exactly we're looking at. As I mentioned, we looked at this area. We worked closely with the parish engineers and the drainage district engineers to see where the biggest problems were in this area. While the recon study only looked at Bayou Dienne, speaking with everybody, we noticed, well, y'all are having problems in other areas. So we decided to look at these other streams also. If you can see by the graphic up here where the outlined areas, those are the streams that we're studying in the study. It includes W5, W4, Hippolyte Coulee, Black Bayou, Contraband, Bayou Chupik, Dienne, W16, and Coachee Coulee also. And those are the reaches as far as we went on each of those particular streams. Next slide, please. Okay, so after we decided what our study area was going to be, we then went into the actual study. The first thing we did was collect survey information for each of the streams that you saw on that previous slide. We completed the survey effort, and this information has been turned over to the parish. We then went and put these into our hydraulic models. And this allowed us to create existing condition models for each of the streams in the area. And what this does is it shows you when you have a certain type of rain event, it will show you in what areas you're going to see flooding. So with these existing condition models on Bayou Dienne, you can see, okay, if we have a 10-year event, this area will see flooding. Next, after that, we saw where it was going to flood, so we had to see how can we get this flood stages down. So we went through what we call the alternative process to look at how to lower these stages. We looked at a number of things for each of these streams, dredging, pump stations, detention ponds, and the next few slides you'll see what we did on each of these slides. But we have finished all of the models, the existing conditions and alternative conditions models for all of the streams in the area. We do have one small part on Bayou Contraband to complete, but that's a small part of the entire model job we had. A large part of this study so far has been the hydraulic modeling that we've completed. We spent a great deal of time and about $1.2 million on these models. And they have been turned over to the parish, and they will be a very powerful tool for the parish to use. If we cannot get a project out of this study, the parish does still have these models. So a few years down the road, if they see we're having a problem in a particular area, they can use these models and look at some alternatives they might want, and they will see what effects these will have. So with the modeling completed, we then moved into our alternative analysis, which is the economic portion. And we finished that up for each of them, and we'll get into those results shortly too. Next slide, please. Okay, I mentioned the alternatives that we ran, these reduction measures. I'm not going to go through all of these. I have a slide in a second that will have all the streams. You can see what exactly we did for each of them. But I do want to touch on Bayou Dienne for a second. These alternatives we got because working with the parish, DEQ had a study in that area along with Bayou Dienne Group. And they had some HTRW issues on Bayou Dienne. DEQ did a study very similar to the one that we're doing on how to clean up this particular stream. Their recommendations were the three that you see here: bank-to-bank capping with concrete mat, dredging, and covering with material from a local sediment source. So the parish asked us to see what exactly would happen if we put this in here to clean up this particular stream. And we've got the results of that we'll get to in a few slides. But that's how we came up with the alternatives for Bayou Dienne. With Shupik, we looked at dredging, W16, a pump station at Griffith Canal, and contraband dredging, and a 3.5-acre detention pond. Next slide. W4 and W5 were also dredging. We looked at a 130-acre detention pond in this area. That is a very large detention pond. It's really not that feasible, but we wanted to look at if we had the biggest possible detention pond in the area, and that would lower the stages. Then we could go back and shorten what we were doing. But first we want to see if we had a large one there, if it would have any impacts. With Black Bayou and Hippolyte, we also looked at dredging and culvert replacement. And with Cauchi, we looked at increased pumping, sediment clearing, and dredging also. Next slide. And this shows you what we just went over. The red areas here are where we dredged and on what particular stream. I know it's kind of hard to see from here, but I think you can make out the red, and you see the majority of the alternatives that we looked at did go with dredging. In addition, we've got the yellow here. See if you can tell by W16 and then Cauchi, we got 2 pumping stations, concrete lining a portion of W4, W5 here in the green, then the culvert replacement and bridge replacement along Black and Hippolyte, and finally the 2 detention ponds here. So that's really just an overview of the alternatives that we ran and stuck into our model. Next slide. Okay, so we did our existing condition models. We saw where it was flooding. We thought about what we can do. We had models on that to see if we lowered the flood stages. So now it's time to start screening these potential projects down to see if we could move forward with a federal project on any of these streams. What we looked at first were Bayou Dienne and Bayou Shupik. As the DEQ study and when our environmental team went out showed, there are HTRW issues in these 2 streams. They have some sediment contamination, specifically mercury, dioxin, and furan. Because of this, we had to eliminate those from our alternative screening process. The federal government cannot move forward with a project as long as there are any type of HTRW issues in the area. In order for us to move forward, these issues must be cleaned up. So until these 2 streams do get clean of any of the HTRW issues, we just can't move forward. We cannot recommend a project in any area like that. So because of that, these 2 streams were eliminated from consideration. Next, we looked at Cauchi Coulee. When we ran our alternative condition models, we did not see the flood stage lowering that we thought we would. Just about 0.1 to 0.3 feet was the maximum stage lowerings that we saw with our alternatives. Because of this, we didn't feel it would be prudent to move forward with this stream. We weren't lowering the stages enough to get into any benefits, which we'll go to in a second. But our hydraulic analysis for the other streams did show a general decrease in the flood stages of all the remaining streams. And what this is it varies from stream to stream and from event to event, but in some cases we saw 2 feet drops, sometimes we saw 1.5 feet. It really varies on the event and the particular area of the stream. But the analysis did show lowering of the stages, so we moved forward into the economic analysis part with these streams, 16, W4, W5, Contraband, Hippolyte, and Black Bayou. Next slide. Okay, here we have some of the flood maps that are with the existing conditions models and the proposed conditions models. Again, these are a little hard to see, but this is W16 for a 100-year event. What you're looking at here, the purple is the floodplain with the alternative in place, with the pump station at Griffith Canal. This green area is including the existing conditions floodplain. So the green is where we lowered the stages for this particular stream on a 100-year event. And you see there are some structures in there where you can get a lot of flood damage reduction benefits. And again, that comes into play when we start analyzing what we can move forward with. Next slide. This is the W4, W5 100-year existing versus proposed floodplains. Again, we don't see as much lowerings. You do have our green here and our green in this area. Now this is just the 100-year. When you look at the 1-year event, the 5-year event, there are lowerings also, but if we were to show you all of the floodplain, it would take a lot longer to go through this. We just kind of wanted to give you an idea of what we have generated with these models. Next slide, please. Here's Contraband. It's a little less than the others also. There's some green sprinkled in there throughout. But as you can see with this one, you are getting a lot of flooding in the Contraband area. And a lot of this flooding is reaching structures and causing damages. And that's going to come into play here shortly. Next slide. Here's Hippolyte and Black, the 100-year. We don't have any green on this one, but I want you to pay attention to these two areas. This is the L1 lateral and the L3 and L5 laterals. We did see for the 100-year not much lowerings, but for the 1 and 5-year we saw significant lowerings, and we had a lot of structures in this area. So we ended up getting a lot of benefits from these two areas. Next slide. And here you can see the L3 and L5 for the 5-year event. If you look here at the green, all this area, this is where our models show that running this alternative of the dredging and culvert replacement, this is what was lowered in here. You see we've got a lot of homes and structures in this area. The L1 stream saw the same thing. Unfortunately, we don't have that map here. But we will see, we have a graph next that will show you exactly the damages and benefits we saw from that. Next slide. Okay, this is very hard to see, but what this is where our economic analysis came into play. We took our existing condition models, our economic team went out, and they looked at the structures that were in the area. From there, they can put a value on these structures. They can see as long as water is going and getting into the structures and causing damages, and that's what we have here in this first column. And I can't really see them, but I know some of the numbers, and I'll call those out to you in a second. But you take those damages, those are the without project damages, what you're seeing now from flooding. The next column is when you put our alternatives in place, the dredging, the pump stations. What do the stages lower? And if flooding water was getting into the homes, is it causing less damages now with those alternatives in place? And then our third column is our benefits. That is the difference between the with project damages and without project damages. Now here at Contraband, I know you can't see it, but you'll just have to believe me. We saw about $9 million worth of average annual damages without a project. So that tells us that water is getting into homes on a lot of events for this area, and it's damaging these particular structures. If you look at the next column, that is with our alternatives in place. That number is about, I believe the first number is 9.9, the next is 9.1. What we're getting at is when we put the alternative in place, we did not lower the stages in this particular stream enough to see any reduction in the damages. Therefore, we got very low flood damage reduction benefits in this particular area. We're going to skip over Black and Hippolyte for the moment. Go to Python W16. This number without project damages was about 2.2 million, which you can see that's not as high as the contraband area. So what that's telling us is while there is flooding in the area, you can see that this flooding might not be getting into the homes and damaging the structures. And that's a key part to our economic analysis when we go to try to get these benefits from there. If the flooding is in the street and it's not getting into the homes, we really can't capture those benefits for it. But with this stream, it was about 2.2. Without the project, I believe that's 1.2. Without, either way, it's a very small amount of benefits, maybe 200,000. With W4, W5, we got even less damages. Again, that's telling us while there is flooding, it's not damaging the structures there. I think we have about 1 million in total damages without a project, and then maybe 800,000 with the project. So we're not lowering these damages. We're not getting very significant benefits for any of these particular projects. But when you look at Black Bayou and Hippolyte, particularly the L1, L3, and L5 streams, that's the one that we had pointed out on that floodplain map. We saw a very large amount of damages without a project now. I believe L1 has 7 million, L3 2 million, and L5 4 million. So we're seeing a lot of structure damage. Then, I wish you could see this one. With the project in there, we significantly cut down these damages. We went from about 7 million to 2 million on L1. I can't see the other two, but we ended up having about $9 million worth of benefits from this particular stream. So when we put that project in place, we saw a lot of reduction in the damages for this stream. Next slide, please. Okay, so then we looked at it. This was the stream where we saw the greatest amount of benefits. Well, we wanted to look and see what was exactly causing these benefits. The alternatives we ran were dredging and culvert replacement for this stream. If you look here in your first column, it shows you that $9 million number. That's the benefits with both dredging and the culverts. Next, we wanted to go in and see, okay, what if you only dredged this area? Would you see the same amount of benefits? There you got about $5 million. So you still got a large amount, but not quite as much. Then you look at the last one. This is culvert replacement only on this stream. Our analysis showed about $7.5 million worth of benefits. Where this comes into play is when we are recommending a plan, it has to be both environmentally and economically justifiable. That comes into when we get a benefit to cost ratio on a particular stream. That's where you take these benefits that we've been discussing, which are the damages without a project, the difference between that and the damages with, and then you take your construction costs and you get an average construction cost per year. You compare the two and you get what's called a benefit to cost ratio. You must have a BC greater than 1 to move forward with a federal project. Well, with these particular streams, our construction cost is about $10 million to dredge and replace the culverts on Hippolyte and Black. So when you get a yearly construction cost, you're looking at a pretty good BC ratio with $9 million worth of benefits. Again, if you just look at the dredging, that was about $9.5 million worth of that alternative. You got a good BC again. But if you look at the $7.5 million in benefits with just the culvert replacement, the culvert replacement we costed at about $500,000. So you're going to have a very large benefit to cost ratio with just that one alternative. Next slide, please. So then we move into plan selection, and I hinted to this earlier. Our guidance requires that we must recommend an alternative that maximizes the benefits. So on that previous slide, as I showed you, we had benefits on Black and Hippolyte streams, but to maximize it, we need the one with the greatest BC ratio. With contraband, W16, W4, and W5, W16, W4, and W5, we just did not see the damages in those streams. Again, there is flooding there, but this flooding is not getting into structures and causing damages that we can capture. So we had to eliminate those three. Contraband, we did see the damages, but we just couldn't reduce them enough to catch the benefits that we needed. So all of those had a BC ratio less than 1. But with Black and Hippolyte, our preliminary BCs were greater than 10, which is a very strong BC ratio, which can lead to a very strong project. Next slide, please. And this led us to select our tentatively selected plan, which is on Black and Hippolyte with the culvert replacement. We've got a replacement of a railroad culvert on Tom Hebert, replaced 2 5-foot diameter ones with 2 10-foot. On Gautier, I don't know if I pronounced that right. Gautier Road, replaced a 7-foot diameter with 2 8-foot diameter. And then one on Corbina, 2 6-foot diameter with 2 8-foot diameter. Also replacement of a partial abandoned bridge north of Lincoln Road. And the approximate cost that we came up for this is $500,000. That does not include any real estate costs or mitigations that we would have, but it should not increase dramatically from that cost. Next slide. So what's our path forward now? Next, we have to do what's called an alternative formulation briefing with our division offices. That's going to be very similar to what we just did here. We will go to our division office and explain to them how we went from our 9 streams at the beginning and had to screen these down to just the one project that we have now. Then we have feasibility level design. We should finish that by April 20th. Environmental compliance in April also. We've got to get an environmental assessment and a finding of no significant impacts on the area. Then we'll start our review process, or rather finish it up in July of 2010, and we hope to have a draft feasibility report recommending this plan for approval in August of 10. It will then go to our division offices and our headquarters offices for approval, and hopefully a chief's report seeking congressional authorization for construction in February 2011. So I guess in closing, we started out with a lot of streams on this project, and I know we wanted to get something in each of them, but because of the environmental issues and because of the economic justification that we must have to move forward with a federal project, we had to cut this down to just the one part with Hippolyte and Black. But the good news is it has a very strong benefit to cost ratio, and that is something that they really do look at when they're looking to approve a report and get authorization for construction. So that is good news. And the models, I mean, that is a very big part of this study, these hydraulic models that we finished. And like I said, that will be a tool that the parish can use in the future.